Here are the solutions to the Unit 3 review for problems 1 through 10. Starting with question 1, we have an amount of $42,000 borrowed for 11 years at 7.5% interest, compounded annually. If the loan is paid in full at the end of that period, how much must be paid back? So we're looking for the total amount accumulated at the end of 11 years. So we're going to use the formula A is equal to P times the quantity 1 plus R over N raised to the N times T. So N is the number of compounding periods, R is the interest as a percent, or sorry, as a decimal. So we take this number here and divide it by 100. And then T is the number of years. So here we want to set this up. A is equal to the amount that we're going off of here. The principal amount is $42,000. And then it's 1 plus 7.5% just turns into a 0.075 compounded annually. So that's just one time every year. So then N times T becomes 1 times 11. Then we would just type this into the calculator. We want to round to the nearest dollar. And we should get, we want to label this as with the dollar sign here, $93,056. All right, for question 2, we're solving a system of inequalities here. So this is section 9.1. So here let's use the elimination method. So I want to multiply the first, and it's your choice what you want. I know multiplying by 5 is usually easier, so I'm going to take this, I want to eliminate the y's. I want to take the first equation, multiply it by a 9. Since my signs are opposite, I could just multiply by positive numbers here, and I want to multiply the bottom equation by a 5. So now my first equation turns into a negative 54x plus 45y, and then multiply 9 times 21. 9 times 1 will give us a 9, 9 times 2 will give us 18, so that's not too hard of a problem to multiply here. Multiplying the second equation by 5 will give us a negative 35x minus a 45y, and then that's going to equal a negative 100. So now our 45y's cancel. Here I've got two negatives I'm adding together here, so this is just going to turn into a negative. We'll have 89x. And then over here, 189 minus 100 is 89, so it works out kind of nice. So dividing both sides by negative 89, x is going to equal negative 1. Next, I need to find y. So I'm going to go back into the first equation. So we're going to have negative 6x plus 5y equals 21. Multiply negative 6 by negative 1. That'll give us a positive 6 plus 5y equals 21. Subtract 6 from both sides. So 5y will equal 15. Divide by 5. So y equals 3. So the solution here would be negative 1, 3, or x equals negative 1, y equals 3. All right, for question 3, we're graphing a logarithmic function. So what's going to make it the easiest to do here is to start with the inverse. So let's first rewrite, let's just take the parent graph here, which would become y equals log base 3 of x. What we want to do is turn this into 3 to the y equals x, rewrite it exponentially, and then we turn this into its inverse by saying y equals 3 to the x. So we want to make a table for this. I'm going to do this right here. So if we have x and then y equals 3 to the x. So I'm just going to choose negative 2, negative 1, 0, 1, and 2. So 3 to the negative second becomes 1/3 to the second if I just take the reciprocal. So we get 1/9. 3 to the negative first just becomes 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. So now what I want to do in order to graph log base 3 of x, I'm just going to take these ordered pairs and switch them around. So my first point is going to become a 1/9 and negative 2. So I just switch the x and the y's that I got up here. My second point is going to become a 1/3, negative 1. Switching those two around. Next I'll have a 1, 0. Then we'll have a 3, 1. And then we'll have a 9, 2. So I'm going to graph these first, and then we'll talk about shifting. So if I do 1/9, that's very close to the y-axis here. And I'm going to go down to -2. So we'll put a point right there. Then we'll have 1/3, -1. So we'll put a point about right there. And we'll have 1, 0, 3, 1, and then 9, 2. So we have a graph that starts to look like this. So this is y equals log base 3 of x. So now to graph this, we're just going to shift. And how would this shift if we have an x plus 1 inside the parentheses? Should shift 1 unit to the left. So I'm going to put in a vertical asymptote here at x equals -1. Just like right here, I had a vertical asymptote at x equals 0. So I know it can't go beyond that. And I'll graph this in purple. So I'm going to start just with the 1, 0. So I'm going to go back here, take the easier points. I'm going to shift this point just 1 to the left, and then this point here 1 to the left. Shifting this point 1 to the left will end up right about here, and then that point that was right there at 1/9 -2 will go right about there. So now we'll have a graph that looks like this. So what's in purple is, let's say, g of x is equal to log base 3 of x plus 1. All right, so let's take a look at the domain. So our domain is how far left to how far right. Well, we cannot get past this x is equal to -1, and we can't include it. So it's going to go from -1 to infinity because it goes to the right forever. The range, this graph goes down forever and goes up forever, so that's all real numbers, or -infinity to infinity. Okay, question 4. We're given this function right here, and this represents the number of milligrams of a certain drug that's in a patient's bloodstream H hours after the drug is injected. When the number of milligrams reaches 6, the drug is to be injected again. So how much time is needed between injections? So again, time is in hours. So what we need to do, this is the amount after so many hours. So we're going to say 6, which is going to be the d of h, is going to equal 25 e to the -0.3 h. So we need to solve for h, which is our exponent. What I first want to do is divide both sides by 25, and I'm going to leave it like this. Do not turn it into a decimal. Now what we need to do to bring this exponent down is to take the natural log of both sides. I'm choosing the natural log because there's an e here. So we're going to say the natural log of 6/25 is going to equal the natural log of e to the -0.3 h. And we'll simplify the right side. Now remember, this will just turn into a -0.3 h, because technically it'll be times the natural log of e, which is just 1, or we know that these are inverses of each other. So now h, in its exact form, is going to be the natural log of 6/25 divided by a -0.3. So again, this is the exact form. If you're ever asked for it, we just leave it this way. But approximating, it says, let's round our answer to the nearest tenth. So if you type that into the calculator and round it to the nearest tenth, you should get 4.8 hours. All right, question 5. Money Savers Bank offers a savings account that earns 8% interest compounded continuously. So anytime it's compounded continuously, we should be thinking of the PERT formula. If Jose deposits $1,600, how much will he have in the account after 5 years, assuming he makes no withdrawals? So we're going to round to the nearest cent here. So we just want to know the amount after 5 years. So we're going to have A is going to equal the initial investment is $1,600 times E, and then the R is going to be a 0.08, 8% as a decimal, and then times 5. So we first want to write this out, just type this into a calculator, again round to the nearest cent. Since we're talking money, we need the dollar sign. We should get $2,386.92. All right, here's another system of equations. Notice it says use substitution. Even if it didn't, based on this equation right here, we would want to use substitution because it's already solved for x. So I want to substitute 2y minus 3 in for that x that's right there. So now it becomes negative 2 times the quantity 2y minus 3 plus 5y equals 8. Distribute the negative 2 carefully. Negative 4y plus 6 plus 5y equals 8. Combine the like terms. 5y minus 4y is just y plus 6 equals 8. Subtract 6, y equals 2. Next, we need to still find x. So I'm going to go back up to this equation here. If x is equal to 2y minus 3, x is equal to 2 times 2 minus 3. That's 4 minus 3, so 1. So we have the ordered pair 1, 2, or x is 1, y is 2. Okay, looking at number 7, I was talking about one-to-one functions here. We have to pass the horizontal line test, and graph 1 does that. Now, even though it's right here, this point's included, this one isn't, so this would be a yes. Graph 2 does not pass the horizontal line test, just as an example right here, so that would be a no. Graph 3, also a no, doesn't pass the horizontal line test. Graph 4 does pass a horizontal line test. No matter where I draw horizontal lines, it's only passing through each point once. Graph 5 doesn't pass the horizontal line test right here. Graph 6 does pass a horizontal line test. If I drew a line here, it's only going through one point. No 2 points line up horizontally. So easy enough there, hopefully, for just looking at the graphs. Okay, question 8. A radioactive substance decays. Now, anytime we see a decay, that R value should be negative. So if you're ever asked to set up a formula where it's a decay, if one's not given to you, make sure you put that rate of decay as negative. If it's increasing or growing, that rate of increase or rate of growth would be positive. So here we're given this function where y naught, or y sub 0 here, is the initial amount present, and y is the amount present at time t in days. So our time is in days here. Find the half-life of this substance. So we don't know how much is there initially. It could be any value. We just want to find the half-life. So this amount here is just going to be half of this. So we could just say 1/2 is going to equal e to the negative 0.048 t. So we're trying to figure out after how many days will this substance have half of its amount remaining. So we would just set up 1/2 is equal to e to this exponent that's right here. So now to solve, I'm just going to take the natural log of each side. And this gives me the natural log of 1/2. And over here, we'll just be left with the negative 0.48t. So the exact form is just going to be t is equal to the natural log of 1/2 over negative 0.048. And we'll round to the nearest tenth, so t is approximately, should give us 14.4 days. Always want to label this. But type that in, make sure you're getting the 14.4. Okay, question 9, another compounding interest problem. Caitlin borrowed $8,000 at a rate of 12% compounded monthly. So that would be 12 times a year. Assuming she makes no payments, how much will she owe after 9 years? So we're going to set this up as A is equal to P. We need to use this formula, 1 plus R over N raised to the N times T. So A is going to equal the $8,000. 1 plus 12% would become a 0.12. Compounded monthly would be over 12, and then N times T becomes 12 times 9. Typing this into the calculator, you're going to round to the nearest cent. It should get $23,431.41. All right, and then question 10 for this section of the review is the last question here. The mass of a substance which follows a continuous exponential growth So when we go to set this up, our rate is going to be positive. So a continuous exponential growth model is being studied in a lab. A sample increases continuously, so we're using something of the form like the PERT formula. A sample increases continuously at a relative rate of 5% per day. Find the mass of the sample after 6 days if there were 41 grams of the substance present at the beginning of the study. So if we're talking mass here, we could kind of say M is going to equal the initial mass times E to the RT. So that's kind of following the PERT formula, but instead of using A and P, we use M and the initial amount here. So we could say that M is going to equal, the initial amount is 41 grams, and then E to the 0.05, and we're talking 6 days, so we just multiply it by 6. We're going to round to the nearest tenth here. So we should get 55.3 grams. So if this said exponential decay, we would just put a negative in front of that 0.05.